Welcome back to this learning of machine learning playlist. In the previous videos, we have looked at uh, what a real what a real value of good data or good algorithm means to a machine learning, and we have also understood different types of machine learning systems and what is machine learning. Now we are required to understand what does underfitting or fitting really mean when building a model, right? So let's say um, let's say we are given with a model. There might be many different patterns in data, so we might not be able to connect all the required features, or sometimes we might uh, feel like we might need to include all the features. So there needs to be a balance between having to select the right features and also uh, ignoring certain features. That fine line is what helps us build out the best efficient machine learning models, right? And overfitting and underfitting is a way to go about it. So with this understanding, we should be able to get a rough idea on what best possible feature selections and such things. Yeah. Okay, so let's move on to the code part. So here I have a small Python code snippet that I pasted here. We are using sklearn and Matplotlib to plot this chart here. So as you can see, the degree one chart uh, showcases blue lines, which are blue dots, which are training data points. A prediction line perform performed as part of a result from machine learning model, the actual expected result. So here, if you see, there is high difference between the machine learning model's prediction and the actual result or the true function that we are requiring, right? So this clearly shows an underfitting where many of the training points have been ignored. In case of degree 3, which is this plot right here, so we see the orange line and the blue line almost the green line almost intersecting, meaning uh, the values are exactly what we want and can be generalized to unseen data in future, right? So next thing is degree 15, which is uh, as you see here, the orange line exactly touches the all of the points that are there. So this is like overfitting where the error is absolutely zero at a certain attributes. This should be avoided, and this can be called as an overfitting pattern, right? So yeah, next that we are going to look at is right here with regularization and model fixes. So regularization helps in making the model lot more generalized or lot more meaningful or lot more simpler to understand. So there are few things like ridge uh, and lasso which helps the chart become lot more smoother, right? So regularization helps in limiting overfitting of a model without changing the data, right? So next is there is also few things like bias and variance, right? Bias is relating to underfitting. A linear model, a non-linear data cannot follow. So let's when we talk about bias, bias measures how much a model oversimplifies the problem, right? It is like underfitting or uh, the more basic it is, right? In case of variance, it's overfitting, and which has a high degree model or lot of uh, fluctuations or follows the each and every attribute that are given in data, right? So and this is only sensitive to the training data and doesn't give out good results with test or valid data set, right? This is usually the cause of overfitting as well, right? So yeah, always having to evaluate with test and validation data set is the key. Yeah, we will look at it later. So few fixes for underfitting is having high degree polynomials and add more relevant features and reduce regularization range if too large. Train model for more epochs if the model is not having higher coverage. Overfitting, use a simpler model or uh, reduce add regularization like reads lasso or drop out few things, and collect more data or use data augmentation, remove noisy or irrelevant data, and cross validation to choose model complexity, right? So those are few things. Okay, so overfitting and underfitting can be evaluated best with when tested out with or when compared with valid and test data. So that's a key way to evaluate all these points, and I have showcased few charts here on the same. This is again another example which showcases underfitting, overfitting, and such patterns, right? So, yeah, just take a look at them and just understand the brief concepts of what overfitting, underfitting, and how regularization, bias, and variance helps solve overfitting and underfitting type problems, right? In the next video, we are going to learn about train data and validation data set, and why test data should remain untouched till the very end of the project, or why it should always be kept as a new one, right? Hope you are enjoying this series. Please do not forget to like, subscribe, and share this channel to whoever is looking to learn machine learning. Thanks for watching. See you in the next video.